This is the 12th video, temperature, stress and strain. The topics covered are temperature, stress and temperature, strain. Introduction. Increase of temperature of a free body causes the body to expand. Similarly, the decrease of temperature of a free body causes the body to contract and no stresses are induced. The strain developed in a material due to change in temperature will be called as temperature strain or thermal strain. The thermal strains are strains that develop when a material is heated or cooled and the body is not restrained for deformation. If an unloaded uniform bar is heated, then due to uniform change in temperature, the bar will expand. There will be increase in length of the bar, say delta L T. T stands for temperature. This delta LT is linearly proportional to temperature change, and this increases the length of the bar, which is given by delta LT is equal to alpha T into L, where delta LT is equal to change in length of the bar due to change in temperature. Capital T is change in temperature of the bar. Alpha is linear coefficient of thermal expansion, or sometimes it is only called as coefficient of thermal expansion. L is equal to original length of the bar. Now, what is coefficient of thermal expansion? Coefficient of thermal expansion can be defined as change in length per unit original length per unit degree change in temperature. So this is basically, say if 1 meter or a unit length of rod is heated by 1 degree, then the change in length is coefficient of thermal expansion. So the thermal expansion or coefficient of thermal expansion alpha is equal to delta LT divided by bracket open T into L bracket close. So if I write it as delta LT, then this delta LT becomes alpha into T into L. So now we have seen that if this is the original length of a rod and it is heated and it is allowed to expand freely, then change in length is this blue color, that is delta LT, change in length due to temperature. So this delta LT is equal to alpha into T into L. Now the temperature strain or a thermal strain, if it is called as epsilon T, then it is equal to delta LT, that is change in length due to temperature change, divided by original length L. If this is substituted delta LT as alpha L into T, then alpha L into T divided by L. So LL gets cancelled, so the strain becomes equal to alpha into T. So this formula for strain and this formula for change in length we will be using in doing the calculations. So these are the formulas here, where delta LT is change in length of the bar due to temperature change, T is change in temperature of the bar, which is final temperature minus initial temperature. Alpha is equal to linear coefficient of thermal expansion, epsilon T is temperature strain, and L is original length of the bar. Now let us see how the stress is induced due to temperature change. Now this is the length of the bar L, and if due to increase in temperature delta LT, this blue strip is the increase in length of the bar. Now if the bar is uniformly heated, what happens is, and when it is heated, if this thermal expansion delta LT, we are not allowing it, if we say fix the bar here and the length is fixed and this delta LT is 0, this increase in length is prevented. Now what happens is, the bar will try, suppose this is a wall, this bar will try to push this wall and it will try to increase in length, but this is prevented, and this wall, when it is prevented, this wall will give a force in this opposite direction as shown here, and similarly here the bar will push the wall outside, and from this wall a force P will act in the, like this, in here it will act in positive x direction, here it will act in the negative x direction. So we can very well see that the force which is acting on this bar is compressive, and a compressive force is developed here on both the sides. If this force P is developed, then only it will prevent this expansion of the bar delta L. So delta LT here becomes 0 and the force P is developed. The strain is here 0 and the P force is developed. Due to this force, the stress developed in this bar is compressive. So when we prevent the deformation, this deformation of the body is constrained or prevented, then the compressive stress is induced in the body, and such a developed stress is called as temperature stress. So temperature stress induced will be compressive if the extension or increase in length is prevented and for the increase in temperature. And how much will be the temperature stress or thermal stress? This sigma T will be temperature strain epsilon T into modulus of elasticity. Now this temperature strain is equal to alpha into T, which we saw in the previous slide. So I substitute a value alpha into T into E. So to calculate the temperature stress, we will use the formula alpha into T into E. And if there is increase in temperature, due to which there is increase in length, and if this increase in length is prevented, then the stress developed is compressive. Now suppose that this is the length of the bar and the bar is cooled. Now if the if an unloaded uniform bar is cooled, then due to uniform change in temperature, the bar will contract. There will be decrease in length. Now here I am showing the decrease in length. Initially it is L here and it will decrease by delta L T. But if we prevent now this decrease in length, we are not allowing to come into this position and it is kept here only, then what will happen? When there is decrease in temperature, the bar wants to contract, so it will try to pull it inside this, but because it is fixed here, there will not be any change in length. So what will happen here? Reactive force will be developed like this. Here it will be developed in the positive vector opposite to this, it will be developed in the positive x direction. Here also the bar will try to come inside like this, but it is prevented, and a force will be applied here. A reactive force will be developed here in this direction, negative x direction, and this we can very well imagine that now these two forces are tensile. If this tensile force is developed, then only it will prevent the contraction of the bar, and the bar length will be L. So however, if this deformation of the body is constrained, then tensile stresses are induced in the body. So this tensile stress will act on this rod, and such a stress developed is called as temperature stress. So what is important here to understand is temperature stress induced will be tensile if contraction, that is decrease in length, is prevented and for the decrease in temperature. And again this thermal stress will also be equal to sigma T is equal to epsilon T into E, which is equal to alpha T into E. So the formula remains alpha into T into E, and this stress will be tensile. So if there is decrease in temperature and if we restrain the deformation, then the stress developed is tensile. However, no stresses are induced if the deformation of the body is allowed. The change in temperature of a body causes expansion or contraction of the body. Most of the substances expand on heating and contract on cooling. This is called thermal expansion. It is interesting to know why the level of mercury rises with temperature. The wires attached to electric poles contract or expand with change in season. This is all due to thermal expansion. It has been observed that bottles which are tightly sealed with a metallic lid are easily opened when the bottle is kept upside down in hot water for some time, in such a way that just the lid is immersed in water. In this way, the metallic lid expands and opens easily. Also, the level of mercury rises in thermometer when it is put in warm water, or when the thermometer is taken out from the water, the mercury level drops as mercury expands due to increase in temperature. These are the effects of thermal expansion which we can see. This is about a railroad track that expand and buckle in heat if the free expansion is prevented. Now here this is a railway track. When the rails are railed, then in between the two rails at the joint we provide some gap for the expansion of the rails, and if that gap is not properly provided, then the railway track expands in due to heat and it buckles something like this as shown in figure here. So always there is some gap left between the two rails. In bridges also, when the construction of the bridge is done, in between there are expansion joints which are provided so that if there is any expansion due to change in temperature, that expansion is allowed. Be a master. Thank you.